Hello, hello, hello. So let's see. So I've got a bunch of kids playing video games in the other room. I'm going to try to keep them chill. Uh, let's see. Hello, everybody. Mr. Waddy here. My audio settings are also a little bit weirder than normal. So I just had a question come in regarding finding. Let's see. All right. Someone said no volume. I'm hoping my volume is back on. All right, that's what I thought. I'd left it muted for a while. Uh, so let's see. Regarding the area of a pentagon, I guess I'll quickly show you how to get that. Um, but you won't need to know how to do that on the test. Also, man, I'm not used to drawing on this screen. It's bigger in proportion to what I'm used to. So for the area of a pentagon, you end up needing to know this distance, which is called the apothem, which is from the center to the midpoint of an edge, and you need to be able to calculate the perimeter of the pentagon, right? So the perimeter would be the sum of all those sides. Also, we're assuming this is a regular pentagon, and so the area of a pentagon, let's see, what colors do I usually use, is equal to 1/2 the apothem, that distance, multiplied by the perimeter. So yeah, sorry if I've given you any questions that have required that. I might not have filtered them out well enough. But in order to calculate the apothem, you end up needing something fancier than just the Pythagorean theorem. You need to be able to do trigonometric ratios, which I didn't show you. Yeah, my wife is doing a little bit better. She's still in quite a bit of pain and recovering in the other room. But yeah, surgery went well, 0 complications, so that's good. Here, I'm going to take care of a kid. I got, let's see, number 23 on the review packet. I haven't yet recorded a video on the review packet, but I might be able to throw that together tonight as well, if need be. But I'll pull up some of that right now. Oh yeah, 23. Okay, here we go. I'll show you how we'll cheat this one. Let me screenshot this. So yeah, so there's our pentagon, buddy. So this is from the review packet for the test. Let's see. All right, that kid solved their own problem. They're not playing with toys and right next to the laptop anymore. So this is a prism, and we talked about that the volume of a prism is equal to the area of the base. Was I using purple for base? I think I was. That's what I was. Capital B, base, which, yes, I agree in this case is a pentagon of side length 2, multiplied by the height, which in this case would be the 4 yards. Fortunately, these units all agree. That should also be the case on the test. So we are just going to quickly cheat this by going online and find a regular polygon area calculator. Pull this up. So ours is going to have a but yeah, you won't have to do this on the test. So in this case, I can pick any sided regular polygon, or at least a decent number of them. Or, oh, it looks like I'd be able to enter my own custom value. So we'll do pentagon, we'll enter a side length of 2, and we'll hit, technically yards doesn't, I'll hit calculate, and it's telling me the area is 6.88. So in this case, our problem is, so the area of this base is going to be 6.88, and that would be in yards squared. I'm going to plug that in here, and I have volume is equal to 6.88 multiplied by 4, the height. Fortunately, I've also got my handy-dandy calculator right next to me here, just like my one at school. Multiplied by 4, 27.52. And this is going to be in yards cubed, because that's volume, 3-dimensional figure. So yeah, so that's how you'd end up doing that. I apologize, I still have some problems that have slipped through the cracks. I have those sorts of things. So Yeah, so if you just do a regular polygon calculator, you can kind of calculate those just like so. Let's see if some other questions are coming in. I apologize for the frame rate, super slow. Will I be there at work next week? It depends. I'm hoping, my goal is that I'll be there Wednesday, uh, which would then give us, some time to review before the final. But I can't say definitively if that's the case. Let's see, if we don't do well on the CI on the test, can we do the sheet you left in the folder for credit? Yes, so the chapter 7 or 11 test, I do have a retake ready to go and available. So you could do the retake, which would then improve your percentage score and potentially show proficiency on a critical indicator. But yes, I also have, I think they were some CUDA software worksheets in the folder. If you are able to do those, and I'll probably try to swing by at school and pick them up at some point, I'll be able to determine that you know how to find volume of different solids. Let's see, number 37 on the review packet. Man, yeah, this is definitely lagging out. Hopefully at least my audio is coming in. Let's see. Packet 37. Yes. So there will be some questions regarding composite solids. Let me invert this and screenshot. Yeah, it still fits. So there will be 2 questions at least about composite solids, in which you have 2 figures or multiple figures combined together or one subtracted from another on the test. So make sure you know how to do this.
Hey, Waddy boys, quiet please.
So let's see. So in this case, the volume of the entire object, I'm going to actually draw this little diagram and calculate these volumes separately. So it's going to be the volume of the cube plus the volume of the hemisphere, like so. And I'm going to calculate each of these. If the hemisphere was subtracted, if it was subtracted from the inside of that cube, then I would have a minus sign for those 2 volumes. So let's see. I think they gave us some of the side things. Let me go talk to my kids quick. You guys keep thinking amongst yourselves. Go get Spider-Man. All right, let's see. Okay, 37, the paper one. Okay. Here we go. Yes, you can do the paper version of the volume packets that are in that critical indicator, which I think is G.MDA for modeling with volume. So here we go. Let's label some of our information here. So I know the side lengths are 6 meters, so that's 6, 6, and 6. I know that the diameter of the hemisphere is also 6 meters, which even if that wasn't labeled, the fact that in the diagram it reaches all the way across the cube, I know that this diameter is going to be the same as the width of that cube. Buddy, you can't play here right now. All right, go in the other room. Okay. So that's 6 meters, and if that is 6 meters, the dimension that I do need to calculate this is not the diameter. I need the radius. So the radius would be half of the diameter, which is 3. So for the volume of this cube, it's just going to be area of the base multiplied by the height. And the area of the base is 6 times 6 multiplied by the height is 6. Maybe you just happen to know the volume of a cube formula, and that also would have worked. Now the volume of a full sphere let's take a look at that, is this right here, 4/3 pi r cubed, careful of that cubed, so that's 4 divided by 3, and then multiply by pi r cubed. You also could have think about it this way, 4 times pi r cubed, and then divide everything by 3 at the very end. So there's a bunch of different ways you can do this. Wow, this is tricky watching kids and teaching math at the same time. So let's see. So the volume of a hemisphere, half of a sphere, is going to be 1/2 times that 4/3 times pi times the radius cubed, which in this case is 3. And so let's calculate some of these things. 6 times 6 is 36 times another 6 is that 216? I think so. Yeah. So there's one of those volumes. And on the test, even if all you could do was draw this little diagram that I've got, I still can give you partial credit. It shows you a general understanding of how this is working. Let's see, 3 cubed is 27. That means not 3 times 3, but 3 times 3 times 3. Okay, so careful of that. Remember to type that in a calculator. You end up needing to do, this would be 3 caret button, which I call a mountain, and then 3 to the 3rd power, the way you would do that. Okay. Let's see. 1/2 times 4/3. I can't actually cross cancel here, but let's just say I'm not. I don't need you guys to practice a bunch of fraction stuff and be scared of it. 1 times 4, multiplying across is 4. 2 times 3 is 6. That does reduce, but let's multiply this all out. So let's see, pi times 27. So I'm going to have 4/6, I know that reduces to 2/3, times 84.82. And I'm going to multiply this by 4, and then take that answer and divide by 6. So don't be scared of that. So multiply by 4 and divide by 6. And so the volume of just the hemisphere is 56.55. Sad looking 5 there. All right. So the total volume plus the 216 is 272.55. And these were measured in meters, so this is going to be measured in meters cubed. See, I've got some more questions. Okay, let's see. On question 23, the answer I got was 27.53. Yep, that's close enough. It depends on how many decimal places you rounded to. If I truly entered 6.88 times 4, I probably would have gotten what you had. I technically had used my calculator's approximation, probably out to like 12 digits on that, and that's what ended up occurring. Let's see. Well, while I'm waiting for more questions to come in, let's see. 29 minus 29 to 31. I'm not entirely sure, but yeah, pick one of them. Pick your favorite. I'll go over it. Regarding critical indicators, if you're doing a Khan Academy assignment, make sure I'm your coach and I can see what you've got. And email me, say, hey, I finished the 2 Khan Academy assignments on this critical indicator, so that I know to even bother looking. If you are doing the IXL problems for proofs, send me a screenshot at the end of each of your batches of proofs. So try 10 questions of each, and see what you can do. Let's see. I'm getting a question for. I'm going to give preference to sequence here, and I still might be able to get a review assignment video posted. Well, I don't know. That's probably too optimistic. Yeah, let's do one of these cone problems. I'm going to screenshot all of them. Guys, turn off the music. Yeah, kids playing Zelda on a 2DS with the music up. Regarding the question, I think it was, how many kids do I have? I've got 4 kids that I'm presently watching and 1 wife who just had brain surgery. I'm just trying to keep them all alive today. You know how it is. So let's see. So, 2 separate questions, surface area and volume. So the volume of a cone, we've got that formula here. It's 1/3 the area of the base multiplied by the height. So that's actually incredibly similar to the volume of a pyramid. They're nearly identical. Also, regarding your foldable notes, we didn't have a foldable note with this. So make sure you add that formula into your foldables packet. So make sure you've got that one. I think I did have this formula show up in the foldables. And these formulas I also have on a chapter summary packet over on the side counter. So check that out as well. So let's see. So that's the volume of a cone. The surface area of a cone is a weird one. We'll end up doing that surface area as well. But let's start with volume. Let's see. What's a good choice? Let's do 31. Do 31.
Guys, no yelling.
So for 31, they've given me the slant height, which we have as a cursive L, and the radius of the base. I need to find that real height, the regular H height, in order to calculate the volume. And conveniently, this is a right triangle, so I can use Pythagorean theorem to figure that out. So to find h, I'm going to do h squared plus 7 squared equals 13 squared. Notice that the 13, the slant height, is the hypotenuse because it's opposite of the right angle. So let's see, let's find h first. So h squared plus 49 equals 169. H squared equals 120. And h is going to be approximately a little less than 11, but I'm going to hit second square root. Make sure you guys know how to calculate these square roots on your calculator as well. I'm getting 10.95. So there's my real height. So now if I want to find the volume of this, that's going to be 1/3 multiplied by the area of the base, and the base in this case is a circle. So that's going to be pi r squared, and r is 7, so pi times 7 squared, and then multiply that by my height, which is 10.95. Okay, so let's see. I'm going to go solve some kid problems in a second. You keep working, I'll be right back. All right, putting a kid in timeout. This is awesome, guys. We should do this every day. This is not stressful at all. All right, so let's see. I'm back. Here we go. So let's calculate each of these things. And I've got 7 squared. Remember, exponents happen before multiplication, PEMDAS, back in the day. So 7 squared is 49, right? So 49 times pi. And let's see, 49 pi is about 153.94. Multiply that by 10.95. Our true height, the one that's perpendicular to the base and goes to the vertex of the cone. And let's see, I know I'm skipping. You get the idea. There's more stuff on it. And so I'm going to hit multiply by 10.95. And I get 1/3 times 1685.62. And then divide that. Take this number and divide by 3. You could imagine it's multiplying by 1 and then dividing by 3. It's accomplishing the same thing. So 561.87 is the volume of this object. And these were in meters, so the volume is in meters cubed. Now, for surface area, separate formula. And pay attention on the test to whether or not they're asking for surface area or volume. It would be a shame if you guys lost points for that. And so the surface area of a cone is a different formula. It's pi r squared, which this represents the area of the base. And so you can imagine that, we'll do a top-down view kind of. So there's the area of the base. And then the cone part is represented by pi times the radius times the slant height. And that cone part, it kind of ends up looking like sometimes something like this, where it's the slant height is this value, and we end up kind of having this thing that if I was to roll it up would be a cone. This edge would meet exactly around the circumference of this circle once. But you don't have to know all that. You just got to know the pi RL. So let's see. So for the surface areas here, I'm going to have pi times r squared, which actually is just going to be this, isn't it? I already know the area of the base. I'll write it out, though. Pi times 7 squared plus pi times the radius. So that's the radius right here, 7. Times L, the slant height. It's 13. So that's going to be the 49 pi plus 70 plus 21, 91 pi. And so let's see, 140 pi. Oh, just dyslexified that. So right, 91 plus 49. You don't have to combine like terms like that. You could have converted these to decimals and all that. And the surface area is going to be approximately whatever 140 pi is. So that's 439.82. Now, surface area, right, keyword area, is going to be square units. So even though it's of a three-dimensional object, it's asking the question, right, how much wrapping paper or how much paint would it take to paint the surface of this object? So that's going to be painting the base and then painting around the surface, this lateral surface of it. So it is measured in square units, not in cubic units. And let's see, a couple other questions. I still see, all right, some others here. On the double-sided critical indicators worksheet, if you do one side and you can clearly tell we understand how to do it, will you accept it as done? I might accept maybe doing something like an every other. Because I want to see how you do on the later problems. Not that I'm necessarily expecting you to be able to do the most difficult problems on it, but I'm going to be looking for your general ability on that, so that I'm comfortable seeing your abilities and that you are in fact proficient. Should be allowed to use WadiMath videos on the final. I'm going to say no to that. Yeah, that's a no-go. You will be able to make a quote-unquote cheat sheet, however, a classic 8.5 by 11 cheat sheet, in which you handwrite it, and you can put example problems like this. You can put formula problems, formulas, theorems, but you will also have access to all of your foldables, and I'll even let you use your chapter summary formula stuff as well. So yeah, so that cheat sheet might be helpful. I suppose if you wanted, you could even find an equivalent area of an 8.5 by 11 rectangle, both sides, and make a cheat sheet cone and wrap it up and have the equivalent surface area there. That'd be a pretty crazy thing. Let's see, I'm getting questions on 26 and 32. You guys have 15 minutes left of class. Let me see what I can do here. 26. Ooh, that's a cool looking one. So let's see. These are all volume of a pyramid. Remember, you don't currently have a foldable for pyramids in your spellbook. So make sure you add that formula so that way you'll be prepped for it. So the volume of a cone, or sorry, pyramid and cone, they're very similar, is 1/3 times the area of the base. So the area of the base in this case would be this rectangle multiplied by the height of the pyramid, which is perpendicular to the base and passes through the vertex, right? And notice in this case, this the peak of this pyramid is not above the center of the base, and that's actually okay. It doesn't matter. It doesn't matter at all. As long as the height remains the same, I could theoretically drag this in any direction, and it will still maintain the same volume for that pyramid. So I do multiplied by the height. So in this case, that is a rectangular base. So so that's going to be 10 times 18 for that base. The height is the 5. You could calculate these separately and then bring them all together at the end. It doesn't matter. And the volume is going to be 1/3 of all of that. So I'm going to multiply all these and then divide by 3. If you're a pro with fractions, maybe you could have seen that you could cross cancel some stuff, but I won't fret. So this is 180 times 5. 180 times 5. I don't trust my brain right now. 180 times, is it? No. 900? Maybe. 900. And 1/3 of 900 is the same as 900 divided by 3, which is going to be 300. And this one ends up being exact. And so these were in meters. This is volume. So this is in meters cubed. Right? And so, so yeah, some familiarity with how to operate all these formulas will be good. If we do one full paper on from the folder, you will accept it. Regarding critical indicators, you will need to each folder, if it has, like, I know the proofs one has like 3 separate packets in it. I would want you to do all 3 to demonstrate it. So I'd be looking for all of those. Sometimes the paper ones in the those folders are there for practice before you try something on Khan Academy or IXL. So yeah, you only need to practice as much as you need until you're ready to do it on that. Let's see, question 32. Excellent choice. I ended up throwing this picture of the cone in there so you didn't have to draw it yourself. This one is kind of as tricky as the problems get, in which I know one calculation. I'm going to use one of my formulas backwards and try to do it from there. Hey guys, be cool, okay? Nope, no yelling. So let's see. In this case, I happen to know the volume. Oh, do you guys need a break? You need time out? Okay, no yelling. Get along, please. All right, here we go. So I know the volume, and they want me to find the height. Remember, the volume of a cone is 1/3 the area of the base multiplied by the height. In the case of this base, it is, oh wow, they've given me all sorts of information. I actually didn't even need this piece right there. They want me to find the height, and I happen to know this. So I'm going to plug this in for the volume, plug in what I know, and solve for what I don't. A classic algebra move right there. So I happen to know the diameter is 16, so that means the radius is half of that, which is 8. Everett, that's enough. Griffin, you're done. Quit the game. Put your controller down. Boy, we're just about at capacity for my boys. Being able to handle being self-responsible right now. Let's see. So let's plug this in. So 320 pi is equal to 1/3 times the area of the base, which is going to have a pi in it. The base is a circle, right? So the area of a circle is going to be pi r squared. Griffin, quiet. Yeah, man. Wow, this has been fun. Pi r squared. So pi times the radius, which is 8, not 16. Oh, maybe I would have needed that. Yeah, I guess I did. Multiplied by h, the height. And notice that's not the slant height, that's the true height of the cone that I'm looking for. So let's see. So I'm going to simplify and cancel things out. Let's see. I guess I'll simplify this first. We'll just we could decimalify everything. I'm going to have you guys get a little bit better at this. 1/3, 8 squared is 64, so that's 64 pi times h. Nope, guys, we'll change games later. So to solve for h, let's get rid of the pi's first. So if I divide both sides by pi, this would cancel with that would cancel with that. So 320 is equal to 1/3 times 64 times h. I could get rid of that 1/3 by multiplying both sides by 3. Okay, Griffin, time out. So that's 960 is equal to 64h. And then to get rid of that, multiply by 64, I'll divide both sides by 60. So the most complicated problems are the ones in which you have to use a formula, quote unquote, backwards or inside out. Actually, I'll write this in. And I'll flip it around, right? So this would have canceled with that. So 960 divided by 64 is equal to 15. And the height is a linear dimension. It's not a volume or an area or a surface area. And since this was measured in cubic centimeters, this must be in plain old centimeters. All right. So feel free to email me if you guys do have more questions. Let's see. Is the test multiple choice? No. There are some multiple choice questions on it. Multiple choice, I mean, it's kind of all or nothing. I can't give partial credit on multiple choice problems. Whereas short answer, right? Show me what you know. Write down make sure you show me that you know which formula you would use, even if you didn't know how to use it. Because then I can at least be like, okay, they knew the volume, which formula to apply to the situation, even though they struggled with it. Yeah, if there's only one paper for chapter 11 for critical indicators, then use that. But I would wait for our final exam review or those ACE blocks. Hey, all right, Griffin, you're done. Wow. So, I would recommend showing your demonstrating the critical indicator for volume on this chapter 11 test before you worry about trying to demonstrate it either on obviously the retake or on that extra paper. So yeah, email me if you guys have further questions, and hopefully I see you next week. You guys take